Okay, we want to talk about number 3 here for a minute. Number 3. Several people are saying we need some help. Who has any insights at all to what's going on? Yeah.
We thought it had something to do with number 2, how you find the square of it. And so the square root of 498 was 22, and 19 is the first prime number under 23.
Yeah, we found the square root of 498, and it was 22.34.
The square root of
498.
498. What's 498? It's the biggest number in our list, right?
Yeah.
So 498.
And that was 22.34. And so the two prime numbers that are around that are 19 and 23. 23 is too high.
19 is under that, and 23 is above. Everybody agree those are the two prime numbers that are on each side of that square root? So what?
We just stopped at 19 because 23 would have been too high for it. Because 23 squared is 529, and that's not on our list anymore. So we just stopped at 19.
So how does that guarantee you've got all if we've lined out everything from all the primes from 2 through 19, how does that guarantee that there's not going to be some other numbers that we didn't get crossed off?
The only way I can do it in my mind is that's the flipping point when we were talking about finding the factors. We stopped when we found our flip, and well, 19 is closest to our flipping point. If that makes sense.
So let's go back to the one we did before. Did you have a question, comment?
I was just going to say 19 times 23. If you multiply them, then it's 437. Then 19 times like 27, even though that's not a prime, is like 513. So if you do 19 times 23, and it goes below 498, and then anything above 19 times above 23 is above 498. So and because 19 and 23, I guess
Okay.
I don't know.
Do you remember when we did? I told you about the student who did y equals 60 divided by x, and then he looks at his table, and what did he see? 1 with 60, 2 with 30, 3 with 20, 4 with 15, 5 dozen, 6 times 10, 7 didn't work, 8 didn't work, 9 didn't. I'm saying didn't work. It was a non-whole number, right? A decimal number. 10 with 6, and all of a sudden somewhere in between here and here, it flipped. Where did it do that? At the square root of 60, which we know is between the square root of 64 and the square root of 49. This is what? 7. This is 8. It's got to be 7 point something. So it happened right in here. Now if I give you a number and say, is this number prime or composite? The only thing you have to do is take the prime numbers up to its square root. So I would check 2, 3, I'd forget 4, because if it didn't work for 2, it wouldn't work for 4, right? I'd 2, 3, because 4 got crossed out. 2, 3, 5, I can skip 6, right? And I check 7, and as soon as I check those, if I didn't find a whole number partner, guess what? The number's prime. How do I know that? Only checking up to here for a number as big as 60, because every number has one less than the square root and one more than the square root. And if I have looked all the way up here and haven't found any, there won't be any that are above that. Does that make sense?
No.
In order for me to get to my number, the two factors that when I multiply them give that number, one is always less than the square root of the number, 7 point whatever, and one is always more. So if I've looked all the numbers up to that, I don't need to check beyond that, because if there were no numbers under it, there will be no partners for them that are above it. Does that make sense?
So you do 5 has to be less than the square root of that number? Or, I'm confused on that.
So let's just take the number, let's see, 497. And I ask you, is this thing prime or is it composite? I picked that because I know you all know 498 is not prime, right? But what about 497? Well, if I take the square root, it's 22 point whatever. So all I've got to do is check all of the prime numbers that are less than this. So I'm going to check what numbers? 2, 3, 5, 7, 11, 13, 17, 19, and but it's less than that, so I don't need to worry about 23. Guess what? So I divide these 1, 2, 3, 4, 5, 6, 7, 8 numbers into here, and if I don't get out a whole number answer, what's my conclusion? This is a prime number. Well, how do I know that if I only check up to 19? That's a big number. Because if I don't find any of these going in, their partners that are going to be bigger, there won't be any partners. So that's why I can stop when I've crossed out all the factors of 19. That makes sense? Now, if you're still having trouble, maybe we can get somebody else to say it a different way or whatever. Our time is out. I'd like you to continue on with this for your homework. I don't have you upload this particular one, but bring any questions you might have from it to class, and we'll talk about those on Friday.